Okay, so this is something that we're not necessarily going to get super into in CCP, but that I definitely want to make sure we have a video about. All right, and that's this idea of the fundamental theorem of algebra. So the idea is in any given function, okay, when we produce a zero, right, that is something, that x-intercept, that we can consider a root. And we can figure out how many zeros we can expect as being whatever the n degree is as the max. And we'll talk about what it means when sometimes you have a repeating zero, so that doesn't really count twice. That means the graph bounces off of it. So if we're a third degree function, we have a maximum of 3 zeros. If we're a fourth degree function, we have a maximum of 4 zeros. Let's think of some examples, right, where we don't really reach the full potential there. Right? What I mean is, like, if this is my setup and I look something like this, right? There's 1 0 and there's 2 zeros. This is the example of like a repeating zero tells you that it bounces right off, right? If I was a fourth degree, right, I could have 1, 2, and that's it, right? I might not even ever come down again, right? So it's possible that you don't actually have that many, but it's a maximum of the whatever the degree is, okay? So let's talk about how we take a zero and turn it into a factor, right? It's easy to think about in terms of quadratics, right? If I think of something pretty straightforward like x squared plus 4x plus 3, you'd say, sure thing, Mr. Ricardo, if I factor that, that's x plus 3 and x plus 1, right? 3 times 1 is 3, 3x plus 1x is 4x. But let's think about what that actually means, like to produce a zero, right? For this to be equal to 0, then the actual x value, the actual solution is -3 or -1. So you kind of need to be able to work your way backwards, right? That if I plug in -3 and I get a 0, then that tells me that as a factor, it looks like this, x plus 3. And I know that can be kind of confusing, but it's important for us to think about. Okay. So let's turn this into like a trinomial, right? Like this right here, when I multiply it together, right? If I start by multiplying the first two, it's going to be x squared minus 1x minus 2, right? And then I need to multiply that by x minus 3. We've practiced doing this stuff before, right? I'll do table method to make it easier. All right. Where I need to worry about x and -3, I need to worry about x squared, -x, and -2. So x cubed, -3x squared, -x squared, 3x, -2x, and 6. So the trinomial that we're producing here is x to the third minus 4x squared plus x plus 6. That this trinomial, if I factored it, I could get it to look like this, where these are the 3 factors. Let's think about what the solutions to this are. When does it equal 0? Not at -2, 1, and -3, but at +2, -1, and +3. That's an important thing for me to be keeping in mind, all right? So let's move to the idea of like what would it look like to actually graph something like this, right? I know those are x-intercepts, but I want you guys to think about if I go back to having it in this form here, x cubed minus 4x squared plus x plus 6. The idea is you would be able, 1, -4, 1, and 6, to produce as many points as you need. I already know that there's going to be 2, 0, -1, 0, and 3, 0. The question, right, is does that actually bear truth? And if I said, well, yeah, 2, does this actually work? 2 times 1, 2. Then I'm going to get -2, -4, -3, -6, 0. So I'm not lying. This works, right? Here is where things get interesting, right? So I could repeat this process for a bunch of different other points, right? And be able, 0 is going to be up at 6, right? And be able to have a pretty good idea of what this thing looks like, right? This will come all the way back down, loop up, and this will go like this. Oh, terrible job there. All right, but we get the idea, okay? We were doing that yesterday, graphing, right? Really, I want to teach you guys how you can use synthetic evaluation to factor, okay? So what I want you to be able to do is first ask yourself, is this a factor? And let's think about the terms we've used. Factor, a 0, a solution. If r minus 4 is a factor, then, or not x, but r equals 4 will produce a 0, right? That has to be true. So what we can practice is the art of saying, all right, let me set up my synthetic 1, -3, 3, -23, and say, well, what does happen if I plug in a 4? Is it a regular point or is it a 0? So 4 times 1, 4. Okay, 1, 4, 7. 4 times 7, 28. I got 5. So 4, 5 is still a point. This isn't bad. It just means no, it's not a factor. Okay. So how do we find a factor? Well, the first thing that we want to do is we can actually generate a list of the possible zeros so that I don't have to just guess, right? I can generate a list of the possible roots by taking the last term here, 3, and dividing it by the first coefficient. So it's always super easy when that coefficient is 1. And that's, for CCP, we're certainly going to stay in that zone. So here, 3 over 1, -3 over 1, right? 1 over 1, -1 over 1. And I picked this one on purpose because 3 is a prime number. It makes it really easy for us to do this. So it's super minimal in my roots. So what do? I take a look at this and I say, okay, the possible things that could produce a 0 are x equals 1, x equals -1, x equals 3, or x equals -3. So what I'll do is I will set up my synthetic, and it's trial and error. Trial and error. You will attempt. I always said, start with 1 and -1. I don't know. Those are, to me, that's your easiest approach. All right, so why don't I start with 1 and see what happens? 1 times 1 is 1. 3 plus 1, 4. 1 and 4. Okay, 4. 3. 1 times 3 is 3. And look at that. It works. So let's think about what this means. Okay? This means that x minus 1 is a factor because when I plug in 1 here, I get a 0, right? It produced a 0. And this is where things get interesting. We've factored this out, meaning we've removed an x, and I've now gone down a degree. And look at this. If I ignore the 0, because now it's gone, I've factored it out, I've gone from having a column for x to the third, x squared, x, and my constant, to a column for x squared, x, and my constant. So I've factored out x minus 1, and I'm left with 1x squared plus 4x plus 3. And this is something where you'd say, you know what? I can factor that. That's a quadratic, Mr. Card. I've done that before, right? In fact, we did that earlier in this video. You'd be able to say, I know what that is. That's x plus 1 times x plus 3. So in factored form, and now wow, look at that. Now I've brought it into factored form, and I've found all of the solutions. And I've found all the x-intercepts. So this, I know I'm throwing a lot at you guys in this video. Watch it as many times as need be. I've showed you guys how we can use factored form to help us graph. I've shown you the relevance of when you produce a 0, how do you rewrite that as a factor, and how do you take what's left, this remainder, and actually turn that into what's left after you've factored out that factor. And then, so basically the goal is going to be, this is an easy one, to the third. So the second you factor one thing out, it's already a quadratic, right? Our goal is, if it were a 4th degree, 5th degree, that you could try and get a couple out, get it down to a quadratic, or at least something that's easier to factor. All right, so that's the focus here, is being able to do stuff like this. I hope this video helps. Rewatch it as many times as need be. We're almost done with this chapter.